Hello, my name is İnci. I'm a freshman student of Electrical and Electronics Engineering in Bilkent University. In my Physics 102 project, my aim was to observe the relationship between the water level between the plates and the potential difference of the capacitor and to calculate the dielectric constant of water. Firstly, I want to talk about what a capacitor is. A capacitor is a device that can store electrical charge and potential energy. To establish a capacitor, two conductors are isolated from one another at a certain distance. Each conductor's charge is proportional to the potential difference between them in a fixed proportion. It is known as capacitance. The capacitance is determined by the conductor's size, shape, insulating material if there is any. In this case, this is just only vacuum here, you can see, and distance between them, which gives us this formula. By definition, we can calculate the capacitance using this formula as well. Now I'm going to talk about capacitors in parallel. When capacitors are connected parallel, their potential differences will be equal to each other. Their charges may differ from each other. The total charge of the combination is equal to sum of the charges in each capacitor. Since potential differences is the same for each capacitor, the total charge divided by the potential of one capacitor gives us the equivalent capacitance value. In parallel case, the equivalent capacitance is the sum of all the capacitance of the capacitors that are connected in parallel. We can calculate the equivalent capacitance just like it's done in parallel capacitors when a different material with different dielectric constant is inserted between the plates. Let's assume the part with the material, a capacitor with the capacitance C1, and the remaining part where there is no material, a capacitor with the capacitance C2. C1 will be calculated with this formula, and C2 will be calculated with this formula, where W is the width of the plate, H are the height of the material, and L is the length of the plate. Equivalent capacitance will be equal to sum of these two capacitances, and this gives us this formula. To do the experiment, I used two identical metal plates with a length of 10 cm on both sides, skewers, hot glue, ruler, a plastic container, distilled water, cable sets, a 10-volt DC power supply, multimeter, and a scientific calculator for the calculations. In the first part of my experiment, I made a capacitor. I cut 4 pieces with a length of 1 cm from the skewer because I wanted the distance between the plates to be 1 cm. Then using hot glue, I glued the 4 pieces to the corners of the plates to provide the distance between the plates to be equal everywhere and 1 cm. Now for the observation part. Place the homemade capacitor into the plastic container. The capacitor has to be perpendicular to the ground. Then, charge your capacitor with the power supply. Measure the potential difference using the multimeter and record your data in the table. Start to fill the container with distilled water until it reaches till the top of the plates. Record your data each time with the steps of 1 cm of increased water level and complete the rest of the table. And lastly, for the calculation part, calculate the permittivity of distilled water using these equations. We can evaluate the specific conditions for H equals 0 and H equals L. The ratio of the capacitance gives us this equation. Since WL divided by D's and Q's cancel because they are the same, we get this equation. We will use this equation for calculating the permittivity of distilled water. While doing this experiment, I could not disconnect the power supply because the potential immediately dropped to 0, meaning that the capacitor discharged at an instant time. What I expected was, since Q equals C times V, and I assumed Q to be constant, as I poured more water into the container, V will decrease because of increasing C. I actually observed a decrease. However, it was so small. After that decreasing stopped, I observed that the potential started to increase a bit and stopped after a short amount of time. After that, I realized that by increasing C, we increase the capacity of a capacitor to store more charge in its place. Since I did not disconnect the power supply, Q increased, causing V to increase too. The reason of the potential decrease to be very small is because of rate of increase of C may be greater than the decrease of V, while the capacitor is being charged by the power supply. This experiment failed. However, I concluded that instead of measuring the potential differences between the plates, I could measure the capacitance values and calculate epsilon distilled water, which is permittivity of distilled water, using the ratio of the capacitance values when it is empty and when it is fully filled with distilled water. This experiment was more suitable for observing the behavior of the total charge that can be stored by the capacitor related to the increase of capacitance value by filling the vacuum between the plates with distilled water, which has greater dielectric constant than vacuum.